Very good evening to everyone. I'm Texan from BITM S1G1 and with my teammate Muhammad Shami and Darren and Radwan, we're going to introduce you our project for the BITP 1323 database, which is Library Management System in UTEP. So first thing, we're going to talk about our introduction. Our database system is quite important to our library management so that we can do more stuff, manage more stuff, such between the members and inside the stuff inside lah. Just like for example, the members want to borrow a book. We need to do a book rental, and then we need to specify information about it so that we know we can track the book, where is it, right? And another one is about our database management. It got the rooms and the rooms lah, of course, for you to book so that the members can study or they can do their own activity there, right? So let's talk about the problem statement. We have 4 problem statements. I will choose one to explain, which is our problem statement is to the cause and instill a proper sense of organization of the books and library based on the respective category, which is the category of the book must be the books must be categorized in each category. So for example, like fiction, non-fiction, of course. And then our problem statement the second problem statement is also we want to trim down the time duration spent on seeking, searching and their managing tasks for the staff that are using our library database system, right? And our objective to develop a database system for managing data and information so that our finding the data and searching the data will be faster. And then our objective also to provide a friendlier student access to a platform for gaining information in the library lah, so for our student to search all the stuff become much more easier, right? So let's just explain the library management. The library management, we have 8 rules. I will explain it very fast. Firstly, the book must be classified into different categories so that it won't be messed up. Secondly, the books must have many copies so that we can search the status of the book about the availability. Third, the book must be written at least one author so that we can contact to the author whether they have an extra book or not, if got any loss in the book. And then a publisher also we are included so that we can keep tracking a publisher detail lah. Next, we have 3 types of member, which is the student, lecturer, and staff. And then the members can borrow many books many times and can borrow one or more books for their each loan. And our loan, each loan there has a fine. There's a fine for the loan if you didn't return the book, and then we need the record also. And the members can book 0 or many rooms also for their activities in the library. So for this one, we will end up, and I'm gonna let my group member to explain the next slide. Thank you.
So here is our ERD of a possible library system. Firstly, there are members represented by the members table, and one member can only have one member type, while each member type can have more than one member. Then members can make either one or many bookings for a room, but each booking can only be made by one member. As for the room service, a booking can only be made for one room. Meanwhile, a room can have many bookings over a certain period of time. A member can make either one loan or none. Meanwhile, a loan can only be made by one member. A single loan can either have no fine or a fine assigned to it. But when a fine is assigned, a loan must be made. Each loan can have one or many loan details at one go. Meanwhile, each loan detail can have one loan assigned to it at a time. Each loan detail has a single book copy assigned to it transaction. Each book copy can have one or many loan details assigned to it at a certain amount of time. One copy belongs to a book, and a book copy can have one or more copies of book described in the term book copy. Each book can have one publisher only, and one book category only. But a publisher might have many or no books, and a book category might have many or no books. A book can be written by one or many authors, but an author can write one book only. Meanwhile, a book author can be written by one and only one author, and an author can write either one or many books as an author, as the book author. The data dictionary is very important as it contains information such as what is in the database, who is allowed to access it, where is the database physically stored. The users of the database normally don't interact with the data dictionary. It is only handled by the database administrator. In the room table, there is room ID and room location. Room ID use varchar with 8 units and is the primary key. The room location use varchar with 8 units. In the member type table, there is member type ID, which is the primary key. There is also member type name with the data type varchar 8 units. Max quantity is included with a data type varchar 8 units. There is also a variable called max duration with a data type varchar with 8 units. The next table is the book category table. So here cat book ID is the primary key. A varchar data type with 8 units is used. There is also cat book name, which is made by the data type char with 8 units. In the publisher table, there is a primary key called the publisher ID. It is a varchar variable with 8 units. There is publisher name and publisher address, which are both data type varchar with 35 units. So the next table we have the author table that has a primary called author ID. It is represented by varchar with 8 units. The author name is represented by varchar with 35 units. The next table is the booking table. For the booking ID, it is the primary key, has the variable varchar with 8 units. The date is in date data type, while the room ID, which is reference to the table room as a foreign key, is in varchar data type with 8 units. The start time and end time are all put in place with a timestamp data type. As you can see here, yes. In the members table, there is a primary key member ID with varchar used with 8 units available. There is member name with the data type varchar with 35 units, and email varchar with 35 units also. There is phone that use the data type number with 10 units. Then there is address with varchar 35 units. And lastly, we have the member type ID, where it is the foreign key in reference to the table member type data varchar with 8 units. And here we have the loan table, which the primary loan ID, the foreign key is member ID. There are variables called loan date and due date, both categorized by the data type date. In the book table, the primary key is ISBN, and then we have cat book ID referring to book category table, and publisher ID referring to publisher table depicts the foreign keys of the table. Before that, then we have the other variables like this: book title, edition, you publish, and book quantity. With these data types, as you can see here, these are the data types. Moving on to the book author table, there are two primary keys and two foreign keys. One of them is ISBN, the other one is author ID. ISBN is reference to table book, while author ID is reference to table author. And finally, we have the find table. There is a variable called find ID. That is the primary key. Varchar with units 8 units is used. Find fees with data type number with 9 units is used. Then there is foreign key of loan ID with voucher with 8 units is used. The table link is loan table. This final slide, we have our final table, which is one of them, the book copy table. There is book copy ID, status, and ISBN. Book copy ID is the primary key, while ISBN is a foreign key referring to book table. And the last table, we have the loan detail table. There are two primary keys and two foreign keys. One is loan ID and the other is book copy ID. There is return date and renew date, and there's also renew status. And that's all the table we have in this project.
Hello there. So this is my part here. I will present about creating tables and inserting data. My name is Darren, and I'm from the group consisting of Texan, Redwan, and Shami. So there are 13 tables in our project. They are room, member type, book category, publisher, author, booking, members, loan, book author, find, book copy, and loan detail. So these are the codes that we use to create the tables for our usage in the project. These are all based on the data dictionary, and we will compare them when we do the creating tables part. We use varchar for most of the ID, and we have dates that comprises of the things that require dates. And for this booking table, we use timestamp. Timestamp includes the time and the seconds of the day and date. So it's a more complicated kind of data type. We use that because it's easier for us to actually access the user's needs for extra time detail. So there are members, loan, book, and we have a year published included in the book so that we can detail the details more deeply. There's a book author, find, book copy, loan detail. And now we are heading towards the inserting data part. So for the part of inserting data, we insert 5 rows to each table. And there are rows that are assigned to fully complement the data that are required in the data dictionary. So this makes the SQL query easier to be done in the later parts of the project. These are the data of the inserted data: room table, member type table, book category table, publisher table, author table, booking table, member table, loan table, and all these book table, book author table, fine table, book copy table, and loan detail table. And so that's it. Thank you for watching.
Hello, my name is Radwan. I am from FTMK BITS. So I will continue database project, SQL statement, and relational algebra. In the beginning, I would like to tell you that since we have limited time, I will just present some of the SQL statement and relational algebra in our project. And also I will run some of them on Apex Oracle. So selection and projection. First query is retrieve all rows information. So SQL statement select star from row. Relational algebra statement selection symbol and table name which is row. Another query retrieve ISBN, comma, book title, comma, edition and year published for all books. SQL statement select ISBN, comma, book title, comma, edition, comma, year published from book table. Relational algebra projection symbol and ISBN, comma, book title, comma, edition, comma, year published and book name, table name which is book. So let's select this SQL statement and run it to see the result on the Apex Oracle. Here is the result. 5 rows returned. Back to the slide. Retrieve publisher name and address whose publisher ID PB74 or PB12. SQL statement select publisher name, comma, publisher address from publisher where publisher ID equal PB01 or publisher ID equal PB05. Relational algebra projection symbol publisher name, comma, address. Here we used both selection and projection, and here is the condition which is selection symbol publisher ID equal PB01 or symbol PB05 from publisher table. Aggregation. What is the total number of copies of book copies title in the library? SQL statement select sum book KTY as total number quantity from book. Relational algebra naming symbol BR total number quantity, aggregation symbol and sum book KTY from book table. What is the average number of copies of book title in the library? Here is the SQL statement select average book KTY as average number quantity from book. Relational algebra BR naming symbol BR average number quantity, aggregation symbol average book KTY and book name, table name which is book. How many book titles published after 2012 are exist in the library? SQL statement select count book title as book title number from book where year published greater than 2012. Let's copy this SQL statement and run it to see the result. Sorry, the semicolon here. So book title number 2. Back to the slide. Using two aggregation in one SQL statement. So here is the SQL statement. List the query. List the number of book title and the average number of book copies using round decimal. SQL statement, select count book title as number of book copy, round, average, AVG, book quantity, comma, 0 as average quantity from book. Here is the relational algebra as you see. Grouping. First query. Find the number of book title and total of their copies for each copy book category which are exist in the library. SQL statement, select cat book ID, comma, count book title as number of book title, comma, sum book KTY as book quantity from book, group by cat book ID, order by cat book ID. Here is the SQL statement, naming symbol, number of book title, comma, book quantity, cat book ID, aggregation symbol, count book title, comma, sum, book KTY, and book and table name which is book. List number of book title for each book category that is its average number of book copies more than 5 are available in the library. Here is the SQL statement, select cat book ID, count book title as number of book title from book, group by cat book ID having AVG book quantity greater than 5, order by book ID. Let's copy this SQL statement and run it to see the result. Here is the result. 4 rows returned. Continue. Join using equation and natural. Let's list find ID and find phase for each loan has a find. SQL statement, select find ID, comma, find phase, comma, loan ID, comma, loan date, comma, due date from find natural join loan. Here is the SQL statement as you see and natural join symbol. Join using left and right and full join. Both of them are the same, just you need to change left to right or full. But the SQL statement, they are the same syntax, just change here left join and here change it to right join or full join. Their symbols in relational algebra, this for left join and this for right join and this is for full join. Sub operation. List the publisher ID where there is either a book or publisher. SQL statement, select publisher ID from book, union, select publisher ID from publisher. SQL statement, as you see, we explained this before in selection and projection. Just add union symbol here or intersect union here as the query required from you according to the query. Subquery. List the find ID and find fees which has loan ID in LN0 or LN01 or LN0. SQL statement, select find ID, comma, find phase from find where loan ID in. Here is the subquery, select loan ID from loan where loan ID in the given condition. So let's copy this SQL statement and run it to see the result. Here is the result. 3 rows return. List member ID, member name who has loan. SQL statement, select member ID, member name from members M where exist. Subquery here, select star from loan L where member ID equal m.mid. Here is the relational algebra. That's all about our library management system project, and actually it was really great experience to involve in a team and to work as a member in a team. Personally, I'm so happy with this experience. So it prepared me for the future path career to be used how to work in a team. Thank you so much, and finally I would like to give my deepest thanks for our lecturer, Dr. Noor Azwalina. Thank you.